All right, today we are going to do 10.5, which has a really lame name. I couldn't even come up with a good name for this chapter, for this section. So yesterday we learned about inscribed angles. On Monday. Inscribed angles are angles that are what up to a circle? What does inscribed mean? Yeah, inscribed means right, in means inside, so they're written inside a circle. Today we're going to talk about a few variations on that, but they're going to be very similar. Okay? The first part is going to be very similar to Monday's lesson. All right? So the first part. When tangents and chords intersect. When tangents and chords intersect. Too much?
No, fine.
When tangents and chords intersect. Okay? If a tangent, which intersects at how many points? One. If a tangent and a chord is any line that goes across the circle, intersect, then the measure of each angle is half the measure of its intercepted arc. That definition is almost identical to what we did yesterday. Okay? If I have an inscribed angle, sorry, I'll let you finish the definition.
Yeah.
Sorry. The tangent and a chord intersect, then the measure of each angle is half the measure of its intercepted arc. Okay? Yesterday what we did is I would give you, let's say I gave you 80 degrees. You told me that what was the angle? 40. Because it's half as much. The only difference between today and yesterday is now I have one chord. Notice how I kept the top chord the same? But instead of a second chord, I now have a tangent. And the tangent hits it in one spot. So do you see how this kind of swung out here? Do you see how it swung? This one moved down, and now it becomes this shape. And the arc moved, and the arc became bigger as well. So the arc now is the entire thing. You see how I started in the same location? It's exactly the same formula as yesterday. So if I ask you, let's say if this is 300 degrees for the arc, the angle then, right here, what would that angle be? How do we do this one? How do we do this one? So we need to do the same thing. What's 300 divided by 2? 150. That's all you need to do. They look a little funky because there's no longer two angles inside. But picture this as just an angle, and somebody swung the gate wide open. Okay? So here's the angle, and they swung the gate down. Okay? Does that kind of help at all? Okay. This problem real quickly. Notice your intercepted arc is 228. I just wrote through it. It's 228. So how would I find x? 114. 114 divided by 2. Easy enough? This one, instead of dividing by 2, what do I need to do? So what's it going to be? 236. Oh, sorry, not right there. 236 degrees. Okay? Easy enough? Yeah. All right. We'll do some practice at the end, okay? When lines intersect, Marshall? When lines intersect, lines can intersect in 3 different places relative to a circle. So across your page, draw 3 circles. Draw 3 circles. can intersect. Where's one place they could intersect? They could intersect in the center. That's a little actually too specific. Be a little less specific. In the circle. So it doesn't necessarily have to hit in the center. They could intersect in the circle. I'm actually going to do that for the second one. So one spot they could intersect is in the circle. Notice that it doesn't have to be the center. Okay? So one is in the circle. Does not have to be the center. Michelle? It can be on the circle. And if it's on the circle, it looks like this. What do we call this angle? It's not a point of tangent because tangents only hit it once. What is this called?
Inscribed.
It's an inscribed angle. Did everybody see that that's what we did last night for homework? It's got arrows on it, but do you see the inscribed angle? The vertex is on the circle. So this is on the circle. And this is a inscribed angle. And that's what we talked about in section 10.4. That's what we just did. So we've already covered this situation. We already covered this situation. Today we're going to cover these two. Okay? So we've got on the circle, in the circle, and?
Around the circle?
Be more specific than around the circle, because you can't really have a point around it. Outside the circle is a better way to say it. So if they want to intersect there, there would be one line, there would be your other. So this is outside. Oops. So they can be on the circle, which we already talked about. And then today we're going to talk about both inside the circle and outside the circle. Okay? They're a little more difficult than on the circle. But these two are very similar. Like I said, I hope to finish this lesson early so we can practice before you guys leave. Okay? Your test is looking like it's going to be Friday.
This way?
Yep. That's it. There's only 4 sections. It's really short. Okay. All right. Angles inside the circle. There are a lot of words here. What I'm going to do is I'm going to write down the definition. I'll allow you guys to fill it out, and I do want you to copy that picture down. It's going to be very important. So I'll give you plenty of time. This picture is also in your textbook, however, in case you lose it. It's also in your textbook. So first off, please be well aware that this is only for angles that are inside the circle. Only when they intersect inside the circle. So if two chords intersect inside a circle, be sure to do inside a circle. The measure of each angle is half the sum. Half the sum of the measures of the arcs So if two chords intersect inside a circle, the measure of each angle is half the sum of the measures of the arcs intersected by the angle and its vertical angle. Please write that down. We're going to explain it in a second. If you're finished writing it down, then start drawing the picture very neatly. Make sure you leave yourself enough room. and the equations underneath. So we're going to go over this with the formula and explain the formula really quickly. And then we'll practice 3 times with numbers. And then at the end of class, hopefully we'll have time to practice some more. So once again, this only works for inside the circle. Only works for inside the circle. Any more seconds or so? Is that enough? All right, so the first thing I want you to look at, once you finish, just pay attention to just me for a second. The first thing I want you to do is, I want you to ignore the circle. I want you to only look at the part inside. Okay? So only look at the lines inside. Notice that angle 1 forms a vertical angle over here. So if this is angle 1, this is also going to be angle 1. And that kind of looks like an arc. That didn't help at all. That will also be angle 1. If this is angle 2, this will also be angle 2. Does everybody see that first off? Okay. The second thing to notice, you don't have to find both 1 and 2. If you find 1, you see the straight line? Equals 180. So if I find 1, could you find angle 2? So you only need to find one of them. Okay? Are we cool with that? All right. Now, the formula. The measure of the angle is equal to half. Notice that half comes back. We used half yesterday. Remember, divide by 2, multiply by 2, or on Monday. The new part, though, is that because it's not on the circle, we have to add the sum. So notice that it's half the sum of the arcs that 1 intersects. So see how it intersects both this one and its vertical angle. So its vertical angle intersects that arc. Okay? So it's almost the same, except now we just need to add the intercepted arcs together. Right? It's the same with 2, except instead of these guys for 2, it would be your top and bottom. Does this make sense? A student in the other class asked me, do they add up to 180? No. Not they could, but not necessarily. All right? Does this make sense? Any questions before we move on to some examples?
You said the line that comes down in the middle splits the circle. Splits the angle like one half is like 180.
If it's a diameter, only the diameter does. These are chords, so they can go wherever they want.
Oh.
Okay? That's why I made the point to draw it on the last slide. I made the point to draw it not exactly in the middle, because we can't assume that it cuts it in half. Right? Unless it tells you. All right, so 3 practice problems. Can anybody set these guys up for me using the formula we just developed? Darren?
It is 140 plus 140.
Okay, what else do we need? Ernest? Half? What does that equal for us here? X. That's it. So notice X intercepts with this arc. The vertical angle intercepts with this arc. You add them together, take half of it, set it equal to X. So X equals half That will be 252. Is that correct?
Yeah.
So x then, half of 252 is going to be 126 degrees. Please check your answer. Obtuse, obtuse. If this is 126, how much is this going to be on the top? 126.
And then
How could you figure these two out?
180.
180 minus 126. Okay, so my point is, you don't have to do the long equation to find the angles here. You can just find one and then find the other two. Mauricio?
So since they're not intersecting at the center anymore, you can't do the other thing that you showed us, where we can just do 140 and 160.
Correct. Sorry, not correct. You were correct until the last part. Well, the first thing we talked about in this unit was central angles. Those were angles that met at the center. Okay? The next thing we talked about were inscribed angles. Those were ones that met on the circle. Okay? Those you can only do the 1/2. You don't need to sum anything. I think that's what you were thinking of. Who can do the next one for me? John?
Angle 3
Angle 3?
equals the half
Half?
of 140
140?
plus 130.
Good. I'm not going to solve, but you guys could do that, right, Phil?
Yes.
Okay? The last one is different. Please be careful. Last one's different. Please be careful. Let's try to take a stab at the last one. Michelle.
Okay.
Okay.
Alright. Can I make it example?
Start wherever you want.
Okay. Okay, so 75 degrees
75 degrees equals
times
2 times
3 times
half.
Okay, half. So we're doing 100 plus X.
Very good. Notice that this one, the x has changed its location. That's the only thing that makes this harder. To solve it, it's going to be a bit different as well. To solve it, it's going to be a bit different as well. How should I solve this? Any thoughts, Ernest? You multiply 2 both sides because then that will do what to the half? Kill it. Alright? So if you multiply by 2 on both sides, that will cancel. We'll pull a Hunger Games here on the half. Alright? It will die. 75 times 2? 150 equals 100 plus x. Subtract 100, blah, blah, blah. X equals 50 degrees. Right? Making a little cameo appearance, okay? X equals 50 degrees. Okay. I was on tour. I'm doing a show with Wale. Any questions on this page? Okay. Before we move on, very important because it's going to be a little harder. Just remember, inside, if they intersect inside, it's always going to be the sum. Please write that down. If they meet inside, you need to add them up. Alicia?
When you do the task, when you actually do the problem, do you do like one has 140 and one has 135? Do you do distributive or do you just add the
You know what? That's the nice thing about math. You'll get the same way you like.
Oh, okay.
As long as you follow the rules, you'll get the same answer.
Okay.
Right? Why did I not solve it? Just in the effort of time, it's going to be the same process. Maria? Yep. Maria had a good question. Guys, quiet please. Maria had a good question. For the second one, if you do solve it, it will be a decimal. Completely fine. Okay? All right. We just did inside. Now we have to take care of outside. We did it inside, now we'll take care of outside. I want you to write down the definition. Do not draw all three of these. Only draw this last one. Okay, so write down the definition. Only draw the last one. Once again, all these pictures are in your textbook. All three of them are in your textbook. Okay? If two lines intersect, now we are outside the circle. So if two lines intersect outside a circle, then the measure of the angle, if two lines intersect outside a circle, then the measure of the angle is 1/2. Notice the 1/2 is coming up again. The difference. What does difference imply? Subtraction. So the measure of the angle is 1/2 the difference of the measures of the intercepted arcs. You will notice that the formula is almost exactly the same. Okay? When you finish that definition, please draw only the third picture. Just draw the third one, and I'll explain why in a second. And you'll notice when you write out the formula, you'll see that it looks almost identical. It looks almost identical. Just the third one? Just the third one's fine. Okay. All three of them are in your textbook in case you want to look at them. So now we did inside, now we're going to do outside. They're almost exactly the same, except now it's going to be instead of an add, it's going to be the difference, and it's going to be subtract. Okay. So the other thing you may want to write is outside implies difference. Just to keep your thoughts organized. I tried to come up with, some like clever, I punched my algebra teacher or whatever to remember that. I didn't really have a good one. One of my students suggested if you're inside, you have to be friendly and keep, sort of sum together, keep together. If you're outside, that's where you fight and beat each other up. So that's where you get your differences out. It's a little violent for my liking, but whatever works, okay? So, inside, sum, outside, difference. All right? If you look at the picture, the only reason there's three is there's technically three different ways we could draw this. If you look at the first one is what's it called if it hits 2 points? A chord is just this part. What's the whole thing? It's secant. What's this called? Tangent. So this is a tangent and a secant. This is what? Both tangents, and this is both secants, okay? It really does not matter. No. It really does not matter which one you draw. Notice they're all the same. The formula. The angle is equal to half, just like last time. The big arc minus the small arc. It's very important that you do the big minus the small. If you don't, you're going to get a negative answer. You'll get negative 50 degrees. Well, that can't happen. Well, it can, but not for us yet. Next year. So for now, you can't have negative degrees. All right? So if you get a negative degree, you know you've done it backwards. Must be the big one minus the small one. Same thing here. Your big one is going to be all of the red. The small one must be just that little piece. Big one, red. Small one, blue. Okay? Ernest? Ready to practice?
Yeah.
Yeah.
Oh.
Waiting on Leslie. Leslie, can you look off the speaker? Okay. All right. You want to set that first one up for me? Set that first one up. I heard from you. I heard from you. Somebody I haven't heard from. I heard from you too. She looks remarkably similar. Alicia?
Measure, angle. Oh my god. I mean, I have 78 minus
78 minus 42. Notice that it's minus.
Oh, you have to have to put that for
Thank you.
equals measure, angle.
Yeah, just X is fine. So X equals half. The big piece here is the 78. It's right here. The 42 refers to just this little sliver in here. Okay? Notice how it cuts it just barely into two pieces. Patricia and Mauricio. I'm going to solve this real quick. X equals half. 78 minus 42 is 36. Half of 36 is 18. So X equals 18 degrees. Okay? Next one. Let's try it harder. Okay, I heard from you. And your twin. Me and Al.
Alright, so is it, A? Wait, what is this one?
I know.
So isn't it 30 equals
Very good. 30.
equals half, parentheses, 44 minus A?
Which one's bigger?
Oh, A.
So it's got to be.
A equals minus 44.
There you go. Make sure you do big minus small, otherwise we'll end up negative. Okay? Ernest, how do I get rid of the half? He's been in the bathroom.
I didn't know.
How do I get rid of the half, Gloria?
Multiply by half.
You multiply not by half, but by 2. Multiply both sides by 2.
That's the
Cancels. 60 equals A minus 44.
44 plus.
Add 44 to both sides. You get 104 is equal to A.
That's so cool.
Okay? How do you feel about these? Good? Alright, let's just do one more and I'll pick the hard one. We'll skip the easier one. And then we'll have time to practice a little bit. We need to start passing these. Just take one and pass. We'll skip the first one. Let's just do the second one. What makes the last one hard? Yeah, I don't have an extra value, right? Any thoughts? Any thoughts on how I could find that missing value? How could I find that missing value? Marcia? You could, but if I add another variable, I need to add another equation, because I can't solve it if I have two variables with one equation. That wouldn't help us. Let's try to think of a way we can just keep it with just one variable. You can't like add a lot. Huh?
Would you multiply 58 times 2?
That's a good guess, but that would only work if it were on the circle, remember? That was only from last night's problem. This is outside the circle, so that no longer works. Oh yeah?
Maybe you multiply by 2.
That's what he just said. Oh, the email says, would you use 360? That interests me. Would I use 360?
Could you?
Alright. Say that again. Not quite. Michelle?
So you would like 360 on the other side of the circle, right? So then you would have the 50
other side or total? So Marcel's very close. Everybody look up, please. Guys, Nicole?
Would it be, 1/2 of parentheses of 360 minus
Very close. Very close. I think that's the same thing as Marcel said. If you look at this, so let me help you. If the circle is how many degrees total? If I have a circle and this little chunk is 60, what's left for the other half? 300. How'd you do that? You subtract it. If I have a circle and this little chunk is x, what's the other part? Okay. Just like you did up here, if you know one part, you can find the other part, right? Well, I know that it's an x, even though I don't know what x is, I still know it's x. So I can do 360 minus x for the other half. That makes sense. Does that make sense? It's a hard problem. So then I can just set my equation up. Because I have two locations where x shows up, but it's still just one variable, Michelle. So I say 58 is equal to half. Which one's bigger? So let me do this in different colors. This is going to become 360 minus x. That's all the first part, right? And then minus, what's the other part? X. So notice it's the same process that we did before, but it looks a little funky because this red is the entire thing. It's actually two different numbers here, the 360 and the x. Now we can collect our like terms. One second, Brian. So we get 58 equals 1/2 360. Well, how many minus x's do I have? Yeah, minus 2x. Brian? Okay. How do I get rid of the half? Multiply by 2. This becomes 116 equals, sorry, let me write it in times 2. 116 equals 360 minus 2x. What do I need to do there? Minus 360. That's going to be negative something, right? Negative 2, 40, no, 2, this is a 4, 2, 44, equals, please, students always lose this. Whenever they cancel this, don't forget about the negative sign. A lot of people just write 2x. It's not 2x, it's negative 2x. And your last step, you need to divide by what? By negative 2. So you divide both sides by negative 2, so x would be positive 122. And that's your final answer. Okay? I'm going to give you your homework right now. I'm going to give you your homework. I want you to work on the following problems from the worksheet. I want you to start on the front. Yep. And I want you to do number 2, 5, 6, 9, and 11. If those are super easy and you're bored, go to the back. I included the back. You know, I didn't want to challenge you. I just want to practice here, just today. But if you really want a challenge, I included the back for you guys. So if that really bores you, go to 11 plus on the back. They're much, much harder. Okay? These are just for you right now. Okay? Just for you right now. It's all optional. It's not homework. I want you to do it right now. A homework is right there.
Oh, what is it? That's a problem.
Your homework is on the board.
You were thinking about a ringwood carp?
I love fishing.
I love fish.
I love particularly fishing for trout. They're very fun to catch. They're very pretty fish.
You like fishing?
So, your homework, please be careful on 7 through 9. They're going to try to trick you, so please be careful. We have about 8 minutes left, so I want you to work on those problems that I highlighted. When you come to class tomorrow, please bring this worksheet. We're going to use it again, okay? Please use this worksheet. We're going to practice from it again. Brian? Yes, can we hang on? Let me stop the recording. Any other questions before I stop? You need one, Ernest? Ernest?